I got into this area of self-driving vehicles in 2006. I was running a lab for General Motors looking at embedded computing systems in a car. It turns out that the concept of a driverless vehicle, a vehicle that drives itself, dates back to the 1940s when General Motors was the biggest car maker in the world. And during a World Expo, they actually proposed this idea where a family in a car could be sitting around a table inside the car, talking to each other, maybe playing card games, and the vehicle is driving itself on the highway. So the idea of self-driving vehicle is many, many decades old. It turns out that we at Carnegie Mellon have been working on driverless vehicles since the mid-1980s. We were the very first ones to prototype early generations of driverless vehicles. This car that we have built is the 14th generation of a self-driving vehicle built at Carnegie Mellon University. So we have a 2011 Cadillac SRX, a crossover SUV that has been fully automated. It can drive on highways at highway speeds, even 70 miles per hour. It can take an exit ramp. It can actually take an entry ramp. It can merge. It can change lanes. It's capable of doing all of that. It can actually drive in urban settings, suburban settings, change lanes in a suburban environment, for example. It can actually know the status of traffic lights, stop when it needs to. It can actually go when the traffic light turns green. It understands work zones. It can recognize pedestrians, bicyclists, and then stay away from bicyclists, pedestrians, or follow them at a slower speed if need be. Stay away from the cones and barrels. So it's already capable of doing a lot of very impressive capabilities. There are multiple reasons why driverless vehicles will make a big impact on society, will revolutionize transportation as we know it. First and foremost, about 1.2 million people die every year due to automotive accidents globally. All these fatalities, accidents, and injuries add up to an economic cost of more than $500 billion US dollars every year. Most of these accidents are due to human error, human distraction. Right? Humans can be distracted very easily. So if we can take humans, if you will, out of the driving equation, we expect that these fatalities, injuries, and accidents will drop dramatically over time. So our holy grail, if you will, is to basically take the number of fatalities from automotive accidents towards zero over time. Number two, the average American today commutes for about 51 minutes to and from work, and about 70% of cars have a single driver in them going back and forth. So it's basically 51 minutes of unused time, unproductive time, just getting from point A to point B. Thirdly, there are elderly people and disabled people who, because they have either lost their cognitive capabilities due to old age, or because they are legally blind or physically blind, they cannot drive. They have lost their mobility, therefore they lose their independence, and therefore their quality of life has shrunk dramatically. This will actually basically make a huge change in lifestyle for those people. And a fourth factor is that pollution and environmental effects from automobiles are significant. If cars were driving themselves, they'll actually coordinate, communicate with other vehicles on the road. All of them will be driving at kind of the same speeds, what is called harmonized speeds, and therefore everybody makes forward progress at about, say, 50-55 miles per hour uniformly, and then our commute times will get shorter, and therefore the environment will also benefit. There are two big practical questions that people always ask. One is, how much is going to cost? Secondly, how is it going to look? So let's talk about the cost issue. For this technology to be adopted, it has to be affordable, it has to be maintainable. And we expect that the technology for doing this later this decade, early 2020s, is evolving, maturing very rapidly, and we expect this capability will cost an additional $3,000 to $5,000. Let's talk about the looks of the car. They cannot look like engineering prototypes, and you need to be comfortable with saying that this is my car. It has to have the right color, the shape, the looks and such. So we expect that self-driving cars of the future will look normal on the outside and the inside. So when we built our 14th generation autonomous vehicle at Carnegie Mellon, our self-driving 2011 Cadillac SRX, we made sure that it does look even aesthetically normal even today on the outside and the inside. Over time, more and more of these capabilities will fall into place, and one fine morning, the vehicle will be able to drive itself completely, but that last step will be a relatively small step, will be very natural, will be very organic, very incremental, and even though it looks like a revolution today, it would have been a very simple process of evolution, and bingo, at that point in time, we are being driven around by driverless vehicles.